Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P2238 indicates an issue with the air-fuel AF sensor circuit, specifically the AFS plus line showing low voltage. This DTC is relevant for Honda Civic models from 2006 to 2011. The AF sensor plays a crucial role in determining the air-fuel mixture in the engine by sending voltage signals to the Engine Control Module, ECM, or Powertrain Control Module, PCM. If the AFS Plus circuit experiences low voltage, it may cause poor engine performance, high emissions, or trigger the check engine light. Before starting troubleshooting, make sure to record any freeze data and onboard snapshot. This helps track vehicle performance data at the time the DTC was set, aiding in an effective diagnosis. The AF sensor, located in the exhaust system before the catalytic converter, measures the oxygen content in the exhaust gases. This sensor helps in optimizing fuel injection and maintaining the ideal air-fuel ratio. The sensor is connected to the ECM or PCM via a 4-pin connector, where one of the pins serves for signal transmission, identified as the AFS Plus, red. This component is essential for efficient combustion and overall vehicle performance. If this sensor experiences low voltage, it can disrupt the feedback loop required for the ECM to adjust fuel injectors appropriately. Understanding the wiring and connections between the AF sensor and the ECM is vital in diagnosing the problem effectively. The first possible cause of DTC P2238 is a short in the wiring between the AF sensor and the ECM/PCM. If wiring insulation is damaged, it can create a direct connection to the ground, resulting in a low voltage reading. Secondly, a faulty AF sensor itself may be the culprit. Over time, wear and tear on the sensor can lead to incorrect readings, affecting engine performance. Lastly, a defective ECM or PCM can misinterpret signals from the sensor. The ECM/PCM controls fuel injection based on the AF sensor data. Thus, any malfunction can have cascading effects on engine performance. When DTC P2238 is triggered, one of the most immediate symptoms is the check engine light illuminating on the dashboard. This indicator alerts the driver to an issue that requires attention. Additionally, the vehicle may exhibit poor engine performance, such as hesitation, rough idle, or lack of power, primarily due to incorrect fuel delivery. Increased emissions may also be a noticeable symptom. If the air-fuel mixture is not optimal, your vehicle will likely emit higher levels of harmful pollutants. These symptoms, when combined, highlight the importance of addressing any issues related to the AF sensor circuit promptly. To begin the troubleshooting process for DTC P2238, first turn the ignition switch to the on position, labeled as 2. This action powers the vehicle's electronic systems without starting the engine. The next step is to clear the DTC using the Honda Diagnostic System HDS. Resetting the DTC allows you to check if the fault persists or if it was an intermittent issue. After clearing, check for any pending or confirmed DTCs with the HDS. If DTC P2238 reappears, it indicates an ongoing issue that necessitates further investigation. On the contrary, if the DTC does not reappear, there may have been a temporary glitch or a loose connection. At this stage, check whether DTC P2238 is indicated on the HDS display. If the code is present, proceed to step 4 for further diagnostics. However, if the code does not appear, it may suggest an intermittent failure, which indicates that the system might be functioning correctly at this moment. In such cases, it is crucial to inspect for potential poor connections or loose terminals, specifically at the AF sensor, sensor 1, and the ECM or PCM connectors. These types of intermittent issues often stem from poor electrical connections, which can spontaneously rectify themselves until they fail again. Therefore, visual and mechanical inspection of these connections is necessary. Next, turn the ignition switch to the lock position, labeled as 0, to ensure the vehicle systems are completely off before performing any further diagnostics. Afterward, use the HDS to jump the SCS line. This step is a safety measure that disables the airbag system to prevent accidental deployment during diagnosis. Once the SCS line is jumped, proceed to disconnect the AF sensor, sensor 1, using its 4-pin 4P connector. This step allows you to isolate the sensor from the circuit without causing interference in the subsequent measurements. The correct disconnection technique ensures that you avoid damage to the connector pins, facilitating easier reconnection after tests are completed. Following the disconnection of the AF sensor, the next step involves disconnecting the ECM-PCM connector C, which features 44 pins. This allows for direct access to the wiring associated with the AF sensor line. After disconnecting this connector, check for continuity between the terminal C29 of the ECM-PCM connector and the vehicle's body ground. This continuity test is crucial since it verifies whether there is a correct grounding path in the electrical circuit. The AFS Plus red wire connector at the sensor should show proper continuity. If there is continuity, it indicates that the wire between the ECM, PCM, and AF sensor is intact, leading to the next troubleshooting step. Once the continuity test is conducted, evaluate whether there is indeed continuity between terminal C29 and body ground. If the result is positive, repair any shorts that might be present within the wire connecting the ECM, PCN, and the AF sensor. Such shorts can cause erroneous low voltage readings and need to be rectified before any further steps are taken. It's an essential part of troubleshooting to ensure that wiring integrity is maintained. On the other hand, if the test indicates that there is no continuity present, proceed to step 9, implying that there may be another issue that needs to be examined in the system. After addressing the continuity results, the next step is to reconnect the ECM/PCM connector C. Once secured, turn the ignition switch back to the on position, enabling the electrical systems again. With the ignition on, it is essential to measure the voltage at the AF sensor, sensor 1, using a multimeter on terminal number 2 of the 4P connector. This measurement will provide pivotal data about the sensor's operation. The expected reading is around 2.2 volts. This information assists in understanding if the fault resides within the sensor itself or elsewhere in the circuit. It is critical to ensure that proper measurements are taken to accurately diagnose and address the issue. Upon measuring the voltage between the AF sensor pin and the body ground, verify if the reading is approximately 2.2 volts. If the multimeter indicates this voltage level, it confirms that the AF sensor is indeed failing and requires replacement. As the sensor is pivotal in managing the air-fuel mixture, replacing it will rectify the low voltage condition and restore optimal engine performance. Proceed to step 12, post-replacement, to ensure that all connections are reinstated correctly. If the voltage does not match the expected value, proceed to step 18 for further investigation, as the issue lies elsewhere in the diagnostic framework. Once repairs, including replacing the A-factor sensor, are carried out, it is imperative to reconnect all connectors that were previously disconnected. This step ensures that the entire system is fully operational as intended. Make sure to follow up by clearing any DTCs using the HDS, which resets the system and allows for a fresh start. Subsequently, perform a test drive to ensure everything operates correctly. During the test drive, monitor how the engine responds, observing if the check engine light remains off. This verification process guarantees that the troubleshooting efforts have successfully resolved the issue and that the vehicle is back to normal operation. Preventive maintenance is vital in avoiding recurrence of DTC P2238. Regularly inspecting electrical connectors for signs of wear, corrosion, or damage can help preemptively identify issues that may lead to low voltage faults. In addition, periodically measuring voltage levels could provide early insight into the operational status of the AF sensor. This proactive approach can help avoid more significant issues down the line. Scheduling routine services for the AF sensor can also increase the longevity of the component and subsequently enhance overall engine efficiency. Establishing a reliable maintenance routine can protect against lower performance or higher emissions from the vehicle. In summary, DTC P2238 highlights a low voltage issue related to the AF sensor circuit. Understanding the role of the AF sensor and its connections to the ECM/PCM is essential. Troubleshooting the specific steps, including measuring voltage levels and checking continuity, aids in identifying the root cause of the issue. Repairing wiring shorts or replacing the AF sensor can lead to restored engine performance. Lastly, implementing preventive maintenance strategies can ensure the long-term reliability of the sensor and system. Awareness of this diagnostic code will empower responsible vehicle maintenance and improve overall engine efficiency and lower emissions for Honda Civic owners. Please like and subscribe to the channel. See you next time!